By viewer request, an example on how to solve a 2D heat equation problem. In this problem, Maple actually fails, and I'll show you where it fails and how to do the workaround. Let's get started. So here's the heat equation in 2 dimensions. T is our function, and is a function of position of x, y, and time, little t. The derivative of big T with respect to time is proportional to essentially the Laplacian. For this particular example, we're going to have the constraints of an initial condition for the temperature in this region, and that at the edges that the temperature will not vary from whatever the edges are. Here is what the initial state of the system is. So writing this out in Maple, it looks virtually identical. Here's the heat equation. These are our boundary conditions. There are 4 of them. This is our initial condition where it is a function of some sort of state of the system. Here's the state of the system. What does our system look like? Initially, it looks something like this. Variations above and below the mean temperature. For simplicity of this particular set of solutions, I'm going to actually keep L equal to 1. And when you do, you end up with this double summation, which is not surprising, but it includes this term, which is imaginary at n equals 4. And this is a consequence of it doing the integral involving t sub 0 and not making the assumption that n is a positive integer. So how do we get around this problem? Because we can't plot this. So how are we going to solve the problem of it coming up with this rogue term? Where we're going to redefine the problem, but this time we're not going to tell it what t sub 0, the initial state of the function, is. Again, how do we solve? PD solve. We give it a curly bracket of all the equations, and in this case we're going to need 6 of them. 1, 2, 3, 4, 5, 6. What sort of function we're looking for, and it's useful also to tell it to assume that the constants are positive. The result is still a double summation, but since we didn't tell it what t sub 0 is, we are left with these integrals. And now we can actually define what t sub 0 is. It hasn't performed the integration, but at least it's ready to get started on it. So now that we have our solution, how do we use it? Given the fact we have double summations that go to infinity. We can't use infinity. So what we're going to do is we're going to extract out everything on the right-hand side of this equation, okay, and replace infinity, the symbol, with 12. We could choose any number of terms. I'm going to choose 12. At this point, we can now actually have it calculate the value of these integrals and make a function of it. And here is our solution involving n equals 12. You will notice there is no imaginary term. With this expression, and now we can plot it from 0 to 1 in both directions, setting k equal to 0.1, not that it's necessary. And we can even animate this plot 3D function, again evaluating with k is equal to 0.1. We'll click on it, push play, and you can see it evolve back to an equilibrium given the fact that all the edges are 0. An alternative way is to literally rebuild this function. So we'll have 4 and put in our own summations. And now what we need to do is put in all these terms. Here's the right-hand side of our solution, extracting out the term that is within the double summation. This requires a fair amount of patience. Worst comes to worst, you could do a copy and paste. Have it recalculate now all of the terms given the integrals, and you'll notice now given the fact that I told it n is a positive integer, that n equals 4 term is 0, and we do not get an imaginary or a term that blows up. And now we can make a function out of our solution and in fact build an entire t sub n where we can choose whatever value of n we want to put in for our solution. And here we are going to animate it with 20 terms. We'll click on it, hit go, and again it smooths out to the equilibrium position. Hats off to NM who answered this question on Maple Primes. Maple Primes is a great community for asking tough questions involving Maple. There you're actually going to get the correct answer. If you have other questions or other examples you'd like to see me do, just drop me a line in the comments below.